In this lecture, what we're going to do is solve equations, and we're going to use factoring to help us do that. And the reason we're able to do this is because of what's called the zero factor property. So we all know that 0 times something is, no matter what this is always going to be 0. And it doesn't matter if the 0 is first or second. But what's actually really special is what's called the zero factor property. Okay, what that says is if I have a product of two things, so if I know that R times S is equal to 0, then if I have a product and it's equal to 0, then I must have that one of these factors is a 0. Or both of them are 0, but you're definitely guaranteed one of them is 0. So then R is equal to 0, or S is equal to 0, which also includes or both are 0, which is included in that. But that's a very special property, and because of this, what we can do is, when we have to solve an equation like this right here, if we can actually factor the left-hand side into a product, then we can use this property of 0 to simplify the solution a little bit more. Okay, in its current form, the only way that you would know how to do something like this is to sort of guess and check. But as we learn a little bit more, we're going to see there are several different techniques that we can use. But what we're definitely going to use right now is this property of factoring and this zero factor property. So let's begin and factor the left-hand side. So what we're going to do is we're trying to solve this. We're trying to figure out which x values will give us a solution to this equation. The factorization of the left would be what? Well, we can write this as x equals 0, so x plus or minus something. And what do we have here? Well, we have that the leading coefficient is a 1, so what we could do is just say, okay, well, we have to find two numbers whose product is -6 and whose sum is +5. So if the product is giving us a negative, then one of them is going to be negative and one of them is going to be positive, so we'll have a plus and a minus. And now we have to think about the factors of 6. So factors of 6, what do we have? Well, we have 1 and 6, we have 2 and 3, and are there any others? Well, because we have a plus and a minus, the order could go in either. The order can go either way. Which one's going to work for us? Well, if we want to end up with a +5, which of the two pairs has that the factors are a distance of 5 away from each other? Well, 6 and 1. So if we want to get a +5, then we would want the +6 and the -1. Okay, so now do we see that the product is -6 and the sum of those two is +5? So that's going to work for us. Okay, so that works for the factorization, but how do you proceed with the solution? So solving this is we have to use this zero factor property. So what it says is we have the first factor times the second factor is equal to 0. So at this point, what we can say for sure is x plus 6 is 0, or x minus 1 is equal to 0. You see, that's exactly how we're translating this. We have a product of two things equal to 0, and that'll lead to one of those being 0. So you see that we either have the x plus 6 is a 0, or the x minus 1 is a 0, or simultaneously both of them are 0, but let's see what happens. So if x plus 6 is 0, we could subtract 6 from both sides, and we will get that x is equal to -6. And if x minus 1 is 0, then adding 1 to both sides, we'll have x is equal to 1. So what are our solutions? Either x is -6 or x is 1. Okay, and if you plug in either of these values, let's say we plug in 1, you'd have 1 squared, which is 1, plus 5, so that'll give us 6, minus 6 is 0. So that indeed is a solution, and minus 6 squared would be 36, and then minus 30, then minus 6 would be 0. So these two are definitely solutions. Okay, and that's pretty much how we're going to use this zero factor property again and again and again. So the procedure is factor, make sure that you have something is equal to 0 and it's factored so that you can use this zero factor property. If you had anything other than 0, it's not going to work. Okay, so make sure we have that. So for this next one, let's try to do the same thing. So 3y squared minus y minus 4 equals 0. We have to figure out the factorization for the left-hand side. Now, since the leading term is a 3y squared, we know that we are going to have a 3y and a y. And now we're probably going to do some guessing and checking to make sure that the other two terms match up. So we know that the last term is a negative 4, so the negative 4 means one of them is going to be negative, one of them is going to be positive, and we need to make a negative y. So what are the possibilities there? So with negative 4, we could have so negative 4, all right, sorry. Factors of 4, we could have 1 and 4, and since they're going to have a negative and one could be positive and one could be minus, we could have 4, 1 as well. We could also have 2 and 2, right? And that would go in either order. So if we want to have a negative 1 in the middle term, it looks like what's actually going to work is to make this a negative 4 and this a positive 1. And the reason for that is the middle terms would be negative 4y and positive 3y, which would make a negative y. Right? This is sort of a guessing and checking procedure. So if you looked at the possibilities and wrote them all out there, you would have 3y, you could have minus 1, y plus 4, we could have 3y minus 4, y plus 1, or we could have 3y minus 2, y plus 2, right? In all these cases, we're getting minus 4 for the last one. We could also have 3y plus 1, y minus 4, and we could have the minuses here instead. 3y plus 4, y minus 1, 3y plus 2, y minus 2. And we could eliminate these systematically, but I don't know. This is just by sort of trial and error that you can figure out which one it has to be. I knew that I had to make a minus y, and I was just thinking about, you know, the factors of this, and I could make a minus 4y and a positive 3y, and then when we add those, this is the one that's going to work, right? So the other ones you would reject. You can check this, right? We could check that that's correct. You'd have 3y squared minus 4y plus 3y minus 4, and that's 3y squared minus y minus 4. And that's what we had, right? So that's good. So that's the correct factorization. And now how do we proceed? So now that you have factored it, then the property of 0 says either this first factor is 0 or the second factor is 0. So we have 3y minus 4 is 0, or y plus 1 is equal to 0. And what does that say? Well, adding 4 to both sides gives us 3y equals 4. Subtracting 1 gives us y equals minus 1. So that's one of the solutions. And the other one, we divide both sides by 3. And we have y is equal to 4/3. Or y is equal to -1. And those are our solutions for this one. For our next one, how can we factor this? Well, we have a cubic, which in general could be difficult, right? Except when we have sums of cubes and differences of cubes, we have a factorization for that. But look at this. We actually have a cube and a square and an x term, so we have no constant term. So you see that in all these terms, we have a common factor of x, and we can factor that out. So if I factor out an x, I'm left with x squared plus 5x plus 6 equals 0, right? Now, at this point, I know one of the solutions is going to be x equals 0, right, by the property of 0, and then I would have this remaining thing equal to 0. But let's just fully factor everything, and then we'll use the property of 0. So can we factor this right here? Well, it looks like the factors of this, leading coefficient is a 1, the product is a 6, so, and I need a sum of 5, so plus 3 and plus 2 are going to work for this, right? So the sum is 5 and the product is 6, so that looks correct. And then now the property of 0 works even if you have more than just a product of two things. So at this point, I have these three products, and the property is 0. Since I'm getting this product as 0, then one of those factors has to be a 0. Okay? So what we have is either x is 0, or x plus 3 is 0, or x plus 2 is 0. And subtracting, right, that's one of the solutions. So subtracting 3, we get x is minus 3, and x is minus 2. So those are the solutions, x equals 0, or x is minus 3, or x is minus 2. So it's kind of funny, that one was actually a cubic, and generally cubics are harder to factor, but this one's kind of was not too bad because we had that common factor of x in it. In this next example, we have some fractions, and one method that we used before when solving equations was to multiply by a least common multiple, right? So if I want to get rid of the 7 and the 2, I can multiply by multiple of those two, and they're not common. 2 doesn't divide into 7, right? They're both prime, so the least common multiple would be 14 in this case. So if we multiply this whole equation by 14, what do we actually get? So 14 times 2 over 7 t squared minus 14 times 7 over 2 equals 0. So this is going to get rid of our fractions, right? So 14 divided by 7 is 2, so 2 times 2 is 4, so we'll have 4t squared. And then 14 divided by 2 is 7. 7 times 7 is 49. So we end up with this. Now this looks much better because what do we have? We have no middle term, right? We have a t squared, and we have a 4t squared, and we have minus 49. So we have no middle term, which indicates that maybe this is a difference of two squares. So do you recognize that this right here is actually 2t squared, right? 2t times 2t would be 4t squared, and 49 is 7 squared. So indeed, we do have a difference of two squares. Difference of two squares. And what was the factorization in that situation? The factorization was 2t minus 7, 2t plus 7. And now we can proceed to solve this thing. So the property of 0 would say that now we have either 2t minus 7 is 0 or 2t plus 7 is 0. So then we would add the 7 over, and we have 2t equals 7, or 2t is equal to subtracting the 7 minus 7. Dividing both sides by t, we'll have, dividing both sides by 2, we will have 7 over 2, or t is equal to minus 7 over 2, and that would be those would be our two solutions. Moving on to our next example, we have x plus 2 squared is equal to 9x. So we're trying to solve and find the x values that make this a valid equation. And here is where we really have to be very careful. It's very tempting to try to use some property, right, of, okay, well, the left-hand side is already factored, right? This is x plus 2 times x plus 2. And the right-hand side is essentially factored. So maybe we could do something with those two factorizations. But unfortunately, we can only use that property of 0, okay? We must first write the equation as something equals 0, okay? And once we have this something, whatever that may be, it's going to be some algebraic expression, equals 0, then we can proceed to factor this, okay? But right now we have a factorization is equal to 9x, but that's not 0, so we can't do anything with this. We need to first have an expression equal to 0. So how do we make this side equal to 0? Well, we could subtract over the 9x, right? So we have x plus 2 squared minus 9x is equal to 0. And then we could try to use our property of 0 and factor this side. Now, unfortunately, we can't do something by like factor by grouping or factor out common factor. So we're going to have to actually first expand this and then simplify and then factor. So sometimes you'll be able to bypass that and do something a little bit quicker, but in this case, the 9x and this, you know, they don't have anything in common, so we're going to have to do a little bit of work here. So how do we expand this? Well, this is x plus 2 times x plus 2 minus 9x equals 0. So now that's x squared plus 2x is plus 4x, and then plus 4 minus 9x is equal to 0. And so simplifying this, the 4x and the 9x, we can combine those two and get minus 5x. So we have x squared minus 5x plus 4 equal to 0. And now we're going to factor this. So we're going to have x times, x plus something times x plus something equal to 0. The product of what we're putting in these two has to be positive 4, and the sum has to be negative 5. So since we're getting a sum of negative 5, that tells me that I'm going to have two negatives. And the factors of 4 are 1, 2, and 4. So it seems like we're going to have to do minus 4 and minus 1 so that the sum is minus 5. And that looks like it's correct, right? So x squared minus 4x minus x will give us minus 5x. And then negative 4 times negative 1 is positive 4. So now we have a factorization is equal to 0, which is quite different from what we had up above, right? Up above, we don't have something equal to 0. But now we're in this stage, right? We have something equal to 0, so we can use our property of 0 and say that one of these factors is 0. So x minus 4 is 0, or x minus 1 is 0, which means that x is equal to 4, or x is equal to 1, just adding that to both sides, okay? So those are our two solutions. So our next one is a little bit similar. We have y squared plus y minus 20 equals 2y. And at the moment, we don't have it, so we have something equals 0. So we have to do some simplification. Let's subtract the 2y over here. So we'll have y squared plus y minus 20 minus 2y equal to 0. And the y and the minus 2y will combine coefficients, so that'll leave us with negative 1y. Okay, and now how do we factor this? Well, we're going to have y plus something times y plus something. We're getting a negative for the product, so 1 is negative, 1 is positive. 1 is negative, 1 is positive. And we have to think about the factors of 20 so that their sum will give us a negative 1. Well, the factors of 20 that are close together are 4 and 5, so that probably is going to work for us. So minus 5 and plus 4. I know that I'm going to have to give the larger one the minus because I'm left with a minus as the sum. And if we check this, it looks like it works out y squared minus 5y plus 4y gives us minus y, and then minus 20. So that looks like the correct factorization. Now we can use the property of 0. We have the factors multiplied equals 0, means either the y minus 5 is 0, or the y plus 4 is 0. Adding this over, we have y is equal to 5, or y is subtracting the 4 over is minus 4. And finally, our last example, we have 4x squared plus 4x equals 0. If you look at this, we actually have a common factor here. We have a common factor of 4x. So we can factor that out. If I factor 4x out of 4x squared, I'm left with an x. If I factor 4x out of 4x, I'm just left with 1, right? I've factored out everything, so I'm left with just a 1. And now I can use my property 0. Either 4x is equal to 0, or this x plus 1 is equal to 0. Which means that dividing by 4, x is equal to 0, or x is equal to minus 1.